All right, team. So thank you very much, guys, who have joined, and those who have not joined, please watch videos. So today we will start. Our Python is officially done. So whatever was required as a data scientist for AI ML, so Python is over. Okay, our Python class is over. So then in the next in the roadmap is like advanced Python libraries, okay, which are very important for data science and machine learning. So we will be doing NumPy today and tomorrow two classes. Okay. Then so NumPy is a these are also libraries. Okay, so NumPy is a library which provides the like beautiful or strong functions for mathematical calculations. Okay, and, and after that we'll go for uh, pandas. Okay, so pandas is used to play up with the Excel file. Okay? How to get top bottom five, how to find average, sum, those things will be done by pandas. Okay? NumPy is nothing but numerical pi, so that we will discuss today. Okay? Then this will take two classes. Okay? So things are very big, but whatever is required for us, we will cover that only. After that, we will go for matplotlib. Okay, matplotlib will have like uh, two to three classes. Okay, here we will be able to draw these graphs and all. Okay. So whatever you have done in NumPy and Pandas, right? You you have to do the graphical representation. For that, matplotlib is used. Then we will also learn something about Seaborn. Okay. So Seaborn will also take two classes. Okay. So if you do Python, NumPy, Pandas, matplotlib, and Seaborn, then our like 40 to 50% of data science is done. Okay. Give me a minute. Sorry, guys. There was some noise coming. I had to close my door. So 40 to 50% will be done here. Then we will move to machine learning model deployment and model development. Okay. From here, we'll learn our machine learning. Okay. Then go for deep learning. Okay. After deep learning, we will be doing some neural networks. Okay. Then we'll be moving to generative AI. Okay. Lang chain and lang graph. And then we'll move to agentic AI. So this is the plan now. So we are right now in this stage. Okay. Are you guys able to hear me? Because so say that my network is
Yeah.
stable.
Yeah,
Yeah.
yes,
Yeah.
Kevin.
Okay. Today, what? So little bit of theory about NumPy and like why do we use it? Okay. And show you the roadmap for NumPy. So I've listed somewhere here. So there are quite a lot of functions. So basically, NumPy is numerical pi, and it is developed in the language called C. So this is a library. This is an advanced Python library, which is not developed in Python because Python list is very slow. Okay. Python is very easy and very good for data science. But what happens is for large data sets, right? Like billions or trillions of data, your Python list is very slow. So in order to overcome that slowness, right, scientists have developed NumPy. Okay. So NumPy main functionality is it gives you n-dimensional array. Okay. So you can create arrays of different types. See here, you can find out what shape they are. You can change their shape. Okay. From the array, you can do the easy manipulation. Okay. All those things we'll learn today. So it is very what do you call? It is very useful, guys. Okay, and it is very powerful, NumPy. And the main feature is it provides n-dimensional array. Okay. Let's go to NumPy and understand what is NumPy. So NumPy, as I said, right, NumPy stands for numerical pi. Pi means Python. Right? So it stands for numerical Python. Okay. Second, it is developed. It is a library. Library means collection of functions. Right? So it's a library developed in C. Right? Third one is it provides n-dimensional array. N-dimensional array. Right? And there are a lot of methods, right? So array manipulation is very easy. We'll see how beautifully it done. How beautifully it does. Okay. Array manipulation is easy. Right? Suppose you have developed an array in NumPy like 1, 2, 3, 4. Right? This is an array, not list. If you just multiply it with 5, right, all the elements will get multiplied by 5. Right? So it will become 5, 10, 15, 20. Doing 1, comma 2, comma 3, comma 4 and star 5. So it was not doing that kind of heavy mathematics. What it was doing, it was copying this array and this list 5 times. Right? So your output was 1, 2, 3, 4. Right? 1 minute. Right? Then again the same. So these elements will be repeated 5 times. 1, 2, 3, 4. Again 4. 1, 2, 3, 4. Something. This kind of output was coming. So it was not. These kind of things are not useful for us. Right? So array creation is easy, array manipulation is easy, and main functionality is provides n-dimensional array. Okay, and okay, so now Python doesn't have array, right? So list is not an array. List because in list you can pass int also, right? You can pass float, you can pass string, right? So it is not contiguous. hmm? I mean, it is not homogeneous. It even contiguous is not there. Right? What I'm saying is list when we studied or when we created, right? So that was a collection of heterogeneous objects. But numpy array. Right? Numpy arrays homogeneous. And since this is homogeneous, it will also be stored one after another, one after another. This array will be stored one after another. So this saves memory also. Right? Next one is, since it is
So,
developed in C, all the C libraries are very fast. Yeah,
sorry, bro.
yeah,
How does this actually save memory? Because it's homogeneous, because it's same type, it doesn't have
yeah,
to allocate different memory, is it? We can allocate in the
yeah.
same.
That is one thing. Yes, that is, yeah, that is one thing. And
Mm-hmm.
maybe we don't know, like list elements will be
Mm-hmm.
stored, some will be created here, another element will be
Mm-hmm.
somewhere here, right? Somewhere here,
Okay.
because these are heterogeneous. So somewhere the less is memory, right?
Mm-hmm.
Suppose float takes 64 bits, right? Your boolean takes 2 bytes, something like that. So for
Mm-hmm.
list,
Mm-hmm.
more memory was allocated, right?
Mm-hmm.
Because heterogeneous, suppose you are creating a list of 5 elements. So what you will be doing? You will be putting one here. Suppose you are giving float here, right? Then you are giving ABC here. So this one is int, this one is
Mm-hmm.
float, this one is a string, right?
Mm-hmm.
So because so if you have like multiple, like 1 billion records, right? Or 1 lakh records. So this is going to consume a lot of memory. And numpy array is homogeneous, so it will only take one kind of variable, right?
Mm-hmm.
And even though like int takes 64 bytes, right?
Mm-hmm.
We can restrict it. Okay, numpy has that functionality. Suppose if you want to do a very small calculation, right?
Mm-hmm.
Your task is to like calculate sum or maybe average of some numbers, and you just want to display 2 decimal numbers, right?
Mm-hmm.
So maybe what will you do, right? You will take a float. The float has like 64 bit, not bytes. 64 bits. There is a functionality that you will take float. Okay, you will take float, but you can restrict it into 16 bits. Okay, we'll see how it is done. Okay, you can you can restrict the size. So what will happen? So NumPy array will be created, but each will take only 16 bit. So that way you'll be saving one-fourth of like three-fourth of memory. Right? By default, it takes 64 bit, but if you're doing a small calculation and your RAM size is very small, right? So what will you do? You will go and restrict the sizes of the data types. Right? You don't need 64 bits. You can restrict into 16 bits or 32 bits, something like that. So we'll see those things. This is how it is memory efficient.
Mm-hmm.
Any doubt, Lima?
Okay. No, I think we have the efficiency of no, we have the provision of restricting the how much memory it can be allocated for each data set.
Correct, correct.
Acha, okay.
Yeah. Right?
So we have the really good.
Hmm. So it is fast.
Yeah.
Why it is fast? Because it is developed in C.
Mm.
NumPy arrays are fast because it is developed in C. C, C++. and C and C++ are very fast. Today also, so some of the games, right? Like if you see this very famous game is there.
Roblox.
Roblox is one. There is one.
Minecraft.
Minecraft. So Python and C is a very famous game and it is spoiling kids. Many kids are playing and people are scolding and they're running away from home. One child was some day back. He was escaped from uh, train. His mother scolded it. Okay. Then he left home, and the reason was his exams were there, and he was watching game. Like very addicted games. Even I play sometimes in free time. Sometimes I used to play. Uh, it's very addictive games. You'll feel like why am I being defeated? Okay, I want to win. So okay. So all the game developments they still are happening in C, C++ and some sort of
Mm.
Python libraries are there. Okay. So what did we learn? Summarize. These are important features. So first one, someone. So it's a library developed in C. Okay. It's a library developed in C. Second one, it provides n-dimensional array. So basically array creation is easy here. So you can do n-dimensional. We'll see. It's very interesting, guy. And it's believe me, if NumPy outage happens, right, half of the ML system today will shut down. Okay. In production, if something happens to ML where it is hosted, right? So your entire world's more than half of AI tools will stop working. Okay. So array creation is easy. Then it is fast because it is developed in C, C++. Right? Uh, it is memory efficient because it allows only homogeneous creation of arrays. Right? Array will be homogeneous. You can't have one int, one float, one str. That is not possible here. Right? Uh, so uses less memory. We already did efficient. It is faster than Python list because it is developed in C. Okay? And it supports mathematical operations. Hmm? Finding some difference. No need to uh, run a for loop or while loop and do the this one, right? Just write a plus b. It will add two arrays. It's very easy. Yeah. If you want to subtract something, multiply something, is easy. Right? Sixth, matrix calculation. So matrix manipulation is very easy. We'll see today. It's very easy here. Right? So let us see how to create arrays. There are multiple ways we can create arrays, NumPy arrays. Okay. So array creation, right? Array creation. So first thing is in our Jupyter notebook, right? NumPy is already installed. NumPy is already installed. But if you're doing in plain Python and all, right, you have to first install NumPy. For that, you will be running pip install. One command is there. Pip install NumPy. So let me open my Jupyter notebook. You guys are following, right? How many of you joined today? Okay, who else are missing?
I think it's 9 members.
9 members only. Mathi, okay. Okay, Satish is missing. And who?
Soundarya is missing. She told that her uncle is having some operation today.
Yeah,
She
yeah.
will join tomorrow. Together. And
Think
Prashant is missing.
Prashant is missing. Satish is missing.
Shravani is also.
Shravani is missing. And our Sendil. Sendil is there.
Senthil is there. Yeah.
Hi, Sendil.
Hey, Kedar. Yeah, good morning, Kedar.
Good morning. You don't have NEET exam for your kid?
Tomorrow,
Acha, acha.
I am
This
not
time,
studying for NEET, Kedar.
no, no, no. For your child only, I'm telling.
Yeah, yeah, yeah. No, just kidding, actually.
Yeah. Uh, um, why it is throwing error? 1 minute. Okay. So tomorrow question papers are coming from helicopter, right?
Already came, I hope.
And this time no one found.
As of now, no, nothing.
And NEET exams question papers are getting late, guys. So how
Yeah,
come?
it's very tough, actually, Kedar.
Yeah, very tough. What is the date today? 20th. See, guys, 20th June. Our target is December. Yeah. By January, February, everyone has to get job. Yeah, in data science. All right. So in order to use NumPy, we have to uh, run this command pip install NumPy. Okay. Let's see what happens if I'm installing it. So it says requirement already satisfied. Looks like I have downloaded. Okay. Or it must be already there in Anaconda version. Okay. But if something like you need to check how to check version. You can find in internet, guys. Okay, if it is not installed, just run this. It will install all the required package, and then we are done. Okay. Now, since this is not in Python, right? Uh, and I am using Python editor. We have installed it. Right? But whenever we want to use it, inside your notebook, you have to import NumPy. So the command is import NumPy. Okay. So once you type it, it will get imported. Okay. But what happens is like each time we don't want to write NumPy. Okay. So we'll be just doing it
Bro,
like this.
sorry to
Import
interrupt.
NumPy. Huh.
Bro, I'm trying
Yeah,
to
Rima.
open the Jupyter notebook, but it is showing me some
Hmm.
default installation. It has actually popped up. So what I do is I go new and then a console, right?
Hmm.
I've been using it, but now it is giving me an error saying some credits missing, license of for information. So can I just say no kernel, or what should I say if I have to get this sorted? Um,
I think, yeah. it is throwing some error to this. There is some problem in server. Okay, Jupyter node.
Uh,
But in the browser it must have opened something, right, for you
yeah,
or not?
it opened my Jupyter notebook, but it
So
says platform.
yeah,
Uh,
go and create a file there.
yeah, so I
I'll
create
tell
new.
you.
Yeah, yeah.
Okay, give me a
I've
minute.
been doing the same way, but it is showing me different
Yeah,
messages now.
new Python 3.
I just selected that.
It is working or not?
One second. Let me do it from Python 3, and I'm just selecting JPY kernel, right? So Python 3, I'm selecting that. It says
Okay, can you share a screen? Can you
no
share your
arguments to
screen?
open the. Yeah, I can do that. Yes. Where? Okay, here it is. Entire screen.
Okay. Otherwise, for the betterment of everyone, you just present your screen. I'm
Yeah.
stopping.
Yeah. Stop sharing. Okay, let me share my screen now.
Hmm.
So, share. Yeah, I'm sharing this. Can you see now?
Yeah,
It's just
just
showing
type
this.
some. This is Jupyter.
Yeah.
Okay, close this. This is not the right one.
Okay.
Open another browser. And I think your screen is not being shared now.
Okay, then I have to share the entire one once again.
Yeah, share the entire screen.
Yeah.
What happened? Not able to share? Lima? Okay, let me present my screen. Fine. So, I'm continuing. So we have installed it. It is already installed for me. Then you have to import Numpy. For that, we are writing import Numpy, and I'm giving an alias as NP because every time giving NumPy is not good. Okay, it it takes a lot of effort. So we have to have an alias for this. Now I am going to create an array. Okay, so suppose I'm giving an array A equal to np dot. Okay, I have to compile this. Np dot. There is a method called array. Np dot array. Just run it. It will.
I'm back, bro.
Okay, no problem. After class we'll do.
Yes, yes. Okay.
Okay. So np dot array, I'm not passing anything. Okay. So first we wanted to see what is the problem. Missing required argument object. So it will take an object. Okay. So what we can do, okay, inside this is we can pass a list or we can pass a tuple. Both is allowed. Okay. So let me create like this. Run it.
Okay.
Now here only we will print A. Okay, this is how we will create. Okay, suppose you want to know what is the type, whether it is a list or something. So just give type of A. So right now, whatever array we have created, A, it is a ND array. ND array means n-dimensional array, and it is of from NumPy. Okay, but if you want to create something using this, right? So let's assume this one, and if you're printing L, right? If you want to know the type of this, type of L. So this is what we have learned so far. Normal list, normal Python list. So it is list. Okay. So this is the difference. Using NumPy, we have to create. Then we have to, what are the steps? First, you have to install it. Second thing is like you have to definitely
Import it.
import,
Mm, mm,
import NumPy. Okay.
mm,
And I'm giving an alias as NP, right?
mm,
And next line you can create, right? Suppose you're creating an array A equal to np dot array. There is a method called array. Okay? Either you can pass here list or you can pass here tuple. Okay,
mm,
and you can print it, print A or simply A, and type of A. Type of A will give numpy dot n dimensional array, nd array, right? Clear.
Yes, Kedar.
So
Can
now
we go
let us
back to
go,
the?
and what is plan? Yeah,
Can we go back to the Jupyter notebook? Just want to see.
yeah.
Okay, it just says empty dot array. What's the first program output? Um,
This is the
okay,
output.
it said, yeah, that is the one, right? Okay, okay.
Yeah, so
So,
it's not
okay, bro, why do we
one
just give
minute.
a there? Yeah, that's what
No,
I'm
no, I
saying.
was trying to print. Sometimes it prints 1, 2, 3, 4,
Okay,
5.
sir. Okay, okay.
Okay, but it's better you give this print everywhere.
Um,
I was trying to save some time.
okay.
Numpy dot nd array. Okay.
Hmm. You just say type, it is coming, but when you just say a, it is not coming. That's the only difference.
Yeah, I think last time it was coming, right? So today there is some problem in server Jupyter node.
Yeah,
One, two,
yeah,
three, four,
it's
five.
coming for me. Yeah, got it.
Okay. So we learn how to create a basic array. Okay. Now we will learn what is dimension. So suppose this is an array 1, 2, 3. Right? This is one array. Okay. Now I have another array 1, 2, 3. All these are 4, 5, 6, 7, 8, 9. These are NumPy arrays, guys. Okay. So we know s- right, if anything like this is getting displayed, right? Suppose this is like your name or roll number. and this is marks. Roll number 1 is having marks 10, 2 is having 20, 3 is having 40. Okay? So 1 minute. So suppose it is your roll number. Okay? This is marks and this is grade. Roll number 1 has marks 10, grade E or F. Okay. 2 has 20, fail. 3 has 70, it is A. 4 has something, I don't know, 4, 80, A plus. So when we write these, eh, what are these? So
Matrix.
the horizontal, yeah, it is a matrix. So matrix. So these horizontal lines, right, are known as row, right? And these vertical lines are known as columns. So this is row 1, this is row 2, horizontal line, row 3, row 4, right? And this is column 1, column 2, vertical lines, column 3. So this is a matrix of how much order? Right? 4 rows are there. Right? Number of rows are 4 and number of columns are 3. So this is a matrix of 4 cross 3. Okay? Clear? Rows and columns.
Yes, Kedar.
So now our task is to create one-dimensional array, two-dimensional array, three-dimensional array, something like that. Okay. So let us come to this helping document. Okay? Now, if I'm creating an array like this, 1 minute. So you only have 1, 2, and 3. So we only have 1, 2, 3. Right? So if it's like only one row, right? It is one dimension. Clear?
Here, Raji.
Okay. So let us understand two-dimensional now. Why it is like that? Give me a minute. So now what I'm doing is right now our matrix is like this. I'm creating array like this. Okay? We have to understand basics, else manipulation will be difficult. So right now we are creating an array like this, np dot array, and your array is like this, 1 comma 2, something like this. Then 3 comma 4, and then 5 comma 6. Right? And you can see here there are two brackets. So basically what is happening, if you just read it like this, it will be like this. Okay? Your this bracket and this bracket. Okay? So you'll work from here to here. This is how you have to interpret. Okay? And these brackets are your one dimensional array. Okay? 3 4 and 5 6. So this is first dimension and this is second dimension, or you can say this is first dimension, this is second dimension. Okay? So it is, how many rows are there now? Can someone please? I said all the horizontal rows will be
3 rows, 2 columns.
so this is row 1, row 2, row 3. Okay? And we have like two columns, column 1, column 2. So this will be a matrix of 3 into 2. Okay? So it is two dimensional, right? Because it has two brackets. If you add another bracket here, it will become three dimensional. Okay? Mostly two dimension and max to max three dimensions we can draw and we can understand. But rest like 100 dimension, 200 dimensions we cannot do. But NumPy supports them. Okay? That is the main purpose we are using NumPy array, because we won't be able to create that kind of matrix, but using NumPy we can do. Let's do that. So what I'm telling it, initially ARR is equal to np dot array. I'm passing 1 2 3. Okay? 1 comma 2 comma 3. Okay? And we are printing array. Clear? So this is printing 1 2 3. Okay? Now I will print type of array. Type of array. So it is giving nd array. Okay? How can we know what is its shape, right? There is a function called shape. ARR dot shape. Will it give? No. Tuple object is not callable. ARR shape and dimension. You're seeing it? It is giving 1. So let us print this fully. Suppose you want to know what dimension it is, you have to provide array name dot endim. What I'm saying is, how will you know the dimensions, right? So I'm doing this. Suppose array is like this, 1 2 3, right? And this is not created directly, it is created np dot array, and inside bracket it is like that. Okay. I will write properly. This syntax you should use np.array, okay? And 2, 3. Suppose I want to know the dimension. What is the dimension for this? Okay? Let's assume I'm printing arr.ndim. I just print it. It will give, this is one dimensional, so it will print 1. 1 means it is one dimensional array. Okay. Now we can do for second 2 dimensions also. Okay. Suppose arr1 equal to np.array. Always type dot and then press tab. It will give you the auto suggestions. Okay. So array1 got np.array. Okay. Now I want to, so 1, 2, 3. Right? This is one dimensional. Okay. Suppose you want to do one more dimensions. What will you do? Okay. Just now we learned. So this will be one array, then comma, give another, then comma, give another, and then close. Right? 4, 5, 6, 7, 8, 9. Okay. So what is happening here? Okay. Wait a minute. Okay. So basically you're writing like this, right? And this and this will come here. Okay. And 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma, 7, comma, 8, comma, 9. Okay. So it is two-dimensional array, correct?
Oh, it's three-dimensional.
Hmm?
How it's two-dimensional? It's three-dimensional.
No, no. So if we give 4 here, it will become four-dimensional. No, no. This is what I'm telling, no? Even though 4 and 5 are there, how many brackets are there? Okay. Inside, see, r- rows and columns are increasing. Okay. But dimension is not about row and column. Right? Dimension is about how many brackets are there. Like suppose one array is there, inside another array is there, and inside another array is there. Okay. Then it will become three-dimensional. But see here, how many arrays are there? This is start, this is end. This is start, and this is end of this. This is start, and this is end of this. This is start, and this is end of this. So we are getting like here to here, and 1, 2, 3, 4, 5. Right? Here 1 to 5 will come, comma. Here 4, 5, 6 are coming. Here 7, 8,
So
9.
for the fourth and fifth, we won't have the pair in matrix, right?
Yeah, yeah.
Yes.
So
Mm.
we'll see how many that doesn't make difference. Okay.
Mm.
Let us run it and see whether it is printing, what is happening. Okay. setting array element with a sequence, the requested array is inhomogeneous shape after one dimension. Okay, the detected shape was 3. So 3 and this is it. So some number you give. Okay? It has 5 elements, so here also 5 elements will come. Okay? I'm just trying to explain dimensions here. Okay, 1, comma 0. Now let us print it. So see, this is row 1, row 2, row 3, column 1, column 2, column 3, column 4, column 5. Right? It has 3 rows, 5 columns. Okay? But it still has 2 dimensions only. Let's print this. Clear? Suppose I'm giving one more bracket here. This kind of scenario will come in our machine learning code and all. Yeah. It is important we understand. Now, what is happening? Like, mm, let us run it first and see whether it's giving 3 or not. It is giving 3. Right? So inside metric, inside one metric, how many matrices are there? This to this is first one. Okay? This to this is second one. Right? And this to this is third. Yeah. No, 1 minute. So the bigger metric is here. Okay? First metric is here. Second one starts ends from here. Okay? Now this is also second. This is also second. Okay? And this is third. This is third. This is third. So if you draw it here, it will be very clear. Likewise are coming. Okay? Right? Here to here and here to here. So basically, see here, no? This is first, this is second, and this is third. Same thing for second item. Okay? First, second, and this will be third. If we increase one more bracket everywhere, it will become 4-dimensional. Okay? So once we 3-dimensional array is possible, let us ask ChatGPT can do it.
Brother, I'm like little confused. So when you say just adding a bracket, it will determine the dimensions or the number
Hmm.
of.
No, number of rows and column doesn't give the dimension. It
Ah,
gives how many rows, how many columns are there.
okay. Mm-hmm.
Okay? Dimension means okay. Dimension means what is shape, right?
Correct. How many?
Something like yeah, Lima. So now this metric, right? What is the shape of
Mm,
this? It has only one bracket, correct? So it is one
It's
dimension.
one single dimension. Okay, got it.
Right? If it has 10 elements, it doesn't mean it is like, right?
Um,
Even though it has 1,000 elements, it will still remain one dimension. Right?
mm,
So second thing is, like, suppose I'm writing two dimensions here. One,
mm,
two, three. Then again I have 4, 5, 6. Right? Now this is two dimension, correct? Because your metric, how it will be written? It will be represented like this. 1, 2, 3, 4, 5, 6. Right? Correct.
mm.
So
So the
you
number
have to
of rows
represent it.
always determines the dimension. Okay, I see.
So number of rows has to be a dimension, not number of column. Okay, we'll see.
Mm,
Okay? Now, even though number of rows are 3 or 4, that also doesn't give
mm,
dimension. So that this confusion only I'm going to
mm.
clear. Okay? Now you're telling number of rows.
Mm,
Suppose I have one row, second row, third row, fourth row, fifth row, sixth row, right? Some element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 16, 17, 18. So now tell how many dimensions are having this is having. right? All are having commas. Now
mm,
see, it is row 1, row 2,
mm.
row 3, row 4, row 5, row 6. Right? Column 1, column 2, column 3. It doesn't mean ki it is like 6 dimension. No, you have to calculate how many brackets are there. First bracket,
Mhm.
right? So inside first, see the order, right? These
Mm.
brackets are at same places, right? And this is like this. This means we have only like two brackets, correct? This is first one and this is second one. So all will have opening and closing. Clear or not?
Yeah, bro. Yeah.
Yeah. So you don't need to worry. You only need to know what is your rows and column, and you have suppose in interview or exam they are asking you to write two-dimensional. Calculate the brackets. Okay? Don't get confused with because in our 10th and all we learned it very wrongly. Okay?
Yeah, that's what I was recollecting.
Yeah.
Old
So
memories.
no. Even teachers did not tell us because in class, right? What happened? There was a necessity of only one dimension and two dimension, not more than that.
Mm.
Okay, so it is still two-dimensional. Let's do this. Array 3 equal to I1, 1, 2, 3. I'm just copying them multiple times. Now we have many. Okay?
Okay.
I don't know. What will be this? Must be integer or slices, not tuples. Where tuple is coming? So now np dot. Let me create like this. Np dot array. Hmm, in bracket. Then we'll add list. Okay. 1, 2, 3 I'm adding. I'm copying it multiple times just to show whether our understanding of dimension is correct or not. So 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times I added. Okay.
Okay.
Now I'm running it. Oh, no, no. Same thing, right? Fine. So this is missing. Now I can another. Okay. 2, 3, 4, 5, 6, 7, 8.
Did you remove the comma at the last row? I think we need to remove that.
Yeah, that is giving trouble.
Yeah.
Okay. So this is array 3. Array 3 dot n dimensions. Right? 2 only. So number of row does not or number of column does not change the dimension. Only these brackets will change. So until 2 dimension it is fine. 3 dimension you cannot create. Then we have to count the number of brackets. Right? Let me ask. Give me a 3D array in Numpy. So what it is telling? Right? See here. 1, 2, 3. 3 brackets are there. So it is also not able to create. Okay. It has increased 1 bracket extra. Correct. It is similar to our array. Hmm. But here brackets are coming after 2 elements.
Mm.
Mhm. 1 minute. Not be like that.
But
Now it is 3. So see here 1, 2, 3. Then one more bracket, one more bracket. Then it is becoming 3. Clear or not? You don't need to worry. Okay. Learn the basics now. Now you know until 2 dimension. If there is a problem until 2 dimension, there is a problem. 3-dimensional and other things will not come. The NumPy will take care of itself because we will be reading data from the Excel sheet, okay, and manipulating it in a array. All these things we are not going to write manually. We'll be creating them. Okay. But I wanted to clear some confusion that number of rows and number of column does not give dimensions. Okay. Number of brackets, that only gives uh, dimension. And this is like, since childhood I have been struggling with this. In some books also it is written like that.
1, 2, 3. That's it.
Okay. So if until here you don't have any doubt, we can proceed further. Okay. Team, is it
Yes,
boring?
Student. No.
I'm taking you to school and all.
Yeah, we can proceed.
Acha, acha, okay. So now we created array with list. We can also create numpy array using uh, tuple. Okay. So I'm giving C equal to np dot array. Very important, guys. All these commands you should practice, then only it will come. Now inside this tuple will come. What is the symbol of tuple? Anyone knows? Now I want to give tuple here. So list we passed in square bracket. Right? How tuple will be passed? Hmm? Using another square bracket. Okay. So list we were passing like this. Right? If you create like this and 1, 2, 3, it will print. It will numpy array from tuple. Right? Sorry, from list. If you're giving like this, it will give from tuple. Compile it, see if nothing happening. Right? Print C dot n dimensions. One dimension is there. Right? And you can also print the array. Okay. 1, 2, 3, 4, 5.
What is C dot? Okay, that's 1. Okay, got it.
C dot, what is the dimension I'm telling? Only
Yeah,
one
yeah.
dimension, right?
Yes.
You are writing in one row and one column.
Mm-hmm.
And one bracket is there. Right? Let's assume I'm writing one more. Will it give two dimensional or not? No. Right? So for that, what we have to do is, in order to make it two dimensional, you can write it something like this. Right? So 1, 2 is a list, 3, 4 is, sorry, a tuple, 5, 4 is tuple, and now compile. Array takes 1, 2, 2 positional argument, but 3 were given. Where did I give 3?
No, we
Okay, we'll see. So mostly from tuple, I don't create. I have not seen in my career itself. Okay, but using tuple also it can be created, and uh, maybe tomorrow I'll do some analysis tonight and give you this. So basically, we'll be creating a numpy array from tuple as well as from list. So mostly list is used, the one which we were doing here. Three D array. Okay, what is next? So we have so we saw number of dimensions, right? We also need to see what is the shape, what is the size. Okay. So let's go up to all that and try to do shape. Five. 1, 2, 3, 4, 5 elements are there. Okay. So it is giving 5. So shape will give the number of elements. 3 elements are there. Okay. Here. What shape will give here? Three, 1, 5. So it is 3-dimensional. One and 5.
What is that one, Kedar?
Yeah, thinking. I'm forgetting some of these concepts. Usually we see the shape. So 1, 2, 3 shape. So I know it is 3 blocks. Right? One first block, second block, third block. So that is giving 3. And it says each block contains 1 row. This is the first row. In second blocks, 1 row, right? And it has each row contains 5 elements. So I'm going to tell you. Okay. Basically, shape. Shape will give you everything actually. So how many blocks? First will be block, and then row, okay? And in each row, how many columns are there? Okay, let's do like this. Okay? So we did 3-dimension. Okay? For 3-dimension, I had written like this: 1, 2, 3, 4, 5. Okay? Then suppose this is also 1, 2, 3, 4, 5. Okay? Right. Okay. So basically, this is our block. So in one block, how many uh, further blocks are there? So we have 3. 1, 2, 3. These are known as blocks. So it
Oh,
is 3 blocks.
2 blocks are
But
there,
if,
right?
but if it
No, no,
two
no.
blocks, right? There's another yeah, we need
Yeah,
to put.
we need to put.
I think end of yeah.
Oh, whatever. Hmm.
One,
So
two,
now
three,
just
three.
think this is one block.
Hmm.
First block means in this matrix, in outer block, how many inner blocks are there? One, two, three. Okay? So it is three blocks. Okay? And in this, so first one is done. Okay? Here to here, inside how many are there? Just count one, two, three. Three blocks are there. Now you count here to here. Okay? No need to count. Now horizontally see how many rows are there. So we have each block has one row. Now this is another block. One. Okay? Now inside this, right? How many elements are there? Number of elements are 1, 2, 3, 4, 5. Correct, right? For two-dimensional, how did it calculate? Okay. Let us do for two dimension. It will be easier to understand. One, two, three. One, two, four, five, six. N dimension. So I'm making mistake here. Right? I should write numpy dot array. Always let us do like this. Yeah. Then only n dimension will come. Two. Now I need to find the shape of this. So let's do like this. This is like this. So we have two two blocks, right?
And three columns, but we don't have a row.
No, row.
Yeah, because the number of columns are three, it has given.
Hmm.
But it has not shown the row, bro. Because
No. It's not
can you just
number.
add
It is not number of column. It is number of elements.
elements? I mean, okay.
Hmm. And two rows.
That's
Okay.
elements. Okay.
1 minute. I'll add one more.
Brackets is elements.
Yeah. P3. So here it is not considering, only it is considering three blocks. Three rows, three columns. It's fine. Okay. Only in more than three dimension only we have to consider blocks and then rows and column. Correct. Here, how it is? Three blocks.
It's
And
for me.
no, n dimension. Array dot say 2, 2, 3.
So we have
Now it,
two blocks, 1 and 2, and then now it is row is 2. What is row there?
no. 3, 1, 5. 3 blocks, 1 row, 9. So did I increase something here?
It's an extra bracket in front of the 7, 8, 9. You see?
No. Yeah, we increased. I want to give you a good explanation. I know I have been using it, but no one goes into such depth and understand for NumPy and all. 2, 2, 3. So 2 blocks, outermost list. Each block has 2 rows. Okay, yeah, it is written in that way only. See here, one list, another list, okay? And this list is closed. Okay? Clear? Suppose I'm removing it, okay, and putting it here 3, 3. That was like that only. 3. Now it will change. So we have 4 rows. Okay? Each row has 3 elements, and we have only one major block. Clear or not? See, this is row.
No, Kedar.
No, huh?
No.
Okay, not clear. What I'm saying is, yeah, 3. Okay? This shape is 3. 3 comma. Okay? So shape is
So,
giving 3 rows. 1 minute. Will with case it will differentiate. Yeah, it will differ. So by default it is taking uh, how many elements are there. Okay, it because it is 1 dimension. Now make it as 2 dimensional. Let's see slowly what happens.
yeah, can we just print the dimension also so that we start? Yeah.
Yeah, you can print.
Mm.
Okay, so when there is no dimension, I mean this is single dimension, right? It's not giving you anything. Only it is giving 3 comma.
Okay.
I'll print all of it. Print save.
One
It is 1
dimension.
dimensional, 3 elements. Okay.
So,
Now
but just a question, maybe we can look into it. Why it is saying 3 comma and as if it has some value there, right?
no, it
You
will
say
not.
3.
This is how it will. Okay? It will
Okay.
only print how many because with the dimension our understanding should. So this is how we should build NumPy and all.
Okay.
These are the libraries written in C, right? And we are trying to interpret in Python, but we will be able to do it. Let's so. Now I'm increasing uh, dimension. Okay. So 1 dimension is increasing. Okay? So let's run it. So it became 2 dimensional. Right? Now we have one row and three column, correct? Shape. So far clear?
Yeah. So let's add another.
Yes, Kedar.
Okay. Now let's add another. So now this will become 3 and it should become, now it will
Three.
3, right?
Block should be 3.
So
Yeah.
here, so we have one block, one big block,
Mhm.
one row and 3 columns, correct?
Mhm. One, two, three, three elements. Three
Yeah,
elements, huh?
3 elements,
Uh-huh.
yes.
Okay.
So shape is not giving anything about dimension. It is just trying to give you the shape. Okay. This like this.
Mm.
Now you're adding another here. Suppose I'm adding 4, 5, 6. Okay. Let's do. So it is one block, outer block, right? In inner block, we have 2 rows. It will be written like this. Okay. And each row has 3 elements. Clear? See, no, in outer block we do not have elements, right? But outer block does not exist if 0 elements are there. It should never print 0. This is outer block. Do we have anything outer block? No. Right? Then in inner block, right, we have 2 rows and 3 columns. That's what in inner block it is printing 2, 3. Right? Increase one more. 7, 8, 9. Let's run. Outer block, nothing changed. Right? In inner block, we have changed one row more. So it became row 1, row 2, row 3, and 3 elements. Correct? If you remove this outer blocks has been removed. Okay. Now we have two-dimensional, and outer block I'm not printing. It will only give row and column. Are you getting now? What I am
Yes,
saying is,
Kedar. Yeah,
yeah,
yes, Kedar. Yeah.
now it will clear it. So add like this. Right? So we have 3, right? 3 dimensions. So definitely it will print 3. And it is giving 3 rows, 3 columns. Right? Suppose I'm increasing one more dimension, right? But I'm not changing anything. Right? So it will give 1, 1, 3, 3. Clear? So this is fourth dimension, third dimension, or maybe you can say this is first dimension, second dimension, third dimension. Inside third dimension only we have 3 rows, 3 columns, right? That's the reason for 3, it is taking how many rows, how many columns are there. Okay. Can someone say I'm increasing one more? What will come now? These 3 dimensions do not have anything, right? Only first, second, third dimension have nothing. Right? So it should not print 0, 0. It should print 1, 1, 1. Then inside this, there are 3 rows, 3 columns. So it should print 1, 1, 1 and 3, 3, which is correct.
Yeah, got it. Okay.
Okay. So with little bit of practice only it comes, guys. Okay. I'm sorry. I'm also forgetting. The theory things are not being used in practice right now. Yeah. So we did. Anyone has any doubt in this?
No, Kedir.
All right. So now we have type and uh, size. Okay. I can directly do for type here. Type. Uh, okay. So suppose age. Now you guys guide me how to create an array now. Devananda, are you there?
Yes,
How
sir.
will I create first array? NP, right? So basically, whenever you will be writing, you will be writing like import numpy as NP. Okay? Now you will be creating a numpy array. Okay. So take array name. Maybe I'm taking D equal to NP dot
np.array.
array. Okay? 1 minute, guys. No? Close this bracket and then pass a list here. Okay. You can create anything. 1, 2, 3, 4, 5. Oh, comma separate. Compile it.
Print array.
Yeah. Print D. So 1, 2, 3, 4, 5 came. Now I want to know the type of this, whether it is int type, float type, right? What will we do? D
Type
dot.
d.type.
Oh my God. So many other D dot D type. Yeah, we don't need C types. D type is there. So you will see it is int 64, right? Here itself, if I will make D type equal to int 16. Okay? Let's see whether this works. How to shorten. Okay, we'll do that in next exercise. So something advanced, but we can do it. Okay. So right now, what type only is to know the type. So type int 64 is coming. Okay. Now, what will happen? Will it work or will it throw error? Let's compile it. Okay. See, what did we learn? So why it is allowing heterogeneous elements? Will it allow? Okay. It allows. I don't know why it is allowing. Fine. So which one is the bigger, right? That will come. Initially, when this was 1, 2, 3, 4, 4, 5, it gave int 64. The moment I changed sum to for float, right, it gave me float 64 because float is the higher order, right? First it start from byte, then int, then float, something like so. Which will have the higher memory that will be taken. Okay, but before that, I want to see why NumPy arrays are allowing any version upgrade has happened. Array allowing type. Instead, it's trying to find a common data type and it can represent all the values. Okay. So 1, 3, 4, 5 integers, 2, 4, 4. Ideally, it should give error. Okay. So it says right, it will take, but storage will be as per contingency. Right? The array elements will be stored one after another. Okay. So d type equal to int. This is what I was trying to type. Now this will give error. Okay. Hmm. So now when you are giving like this, I'm telling that my data, all the types will be integer. Okay. It also then give int 34 or int 32. Will it store? Yes. Int 32 is not defined. Int 32 is defined, right? All right. So what we are doing is we created an array, right, using NumPy, and if we are not telling anything, so by default it will take the size of integer. So it is int array 1, 2, 3, 4, 5. So d type, its data type is int 64. Okay. When you take some float value, okay, its data type will be changing to, now 1 became 1.0, 2 became 2.6, 3 became 3 point something. Right? So everything becomes float. Right? If you still want to have everything as int, right? So you can type d type is equal to int, suppose 16 I'm doing. Right? Will it work? Yeah. So now I'm saving memory. Right? What I'm doing, I'm saving memory. Right? How I'm saving memory now? So you created a NumPy array A is equal to NumPy dot array. Okay. And you're passing a list 1, 2, 3, 4, 5. Okay. And when you print A dot D type, so it is telling it is int 64 bit. So this element will take 64 bit, second will take 64, third 64, fourth 64, 5 64. So total memory will be how much? Okay. Memory total will be now 64 into 5. It is 330 bit, 620 bit. Okay. But you can also restrict it. Okay. NP by array. So suppose here like 1 lakh records are there. 1 lakhs into 64. Okay. So you need 64 lakhs bit. Okay. So this much memory for a small array. Suppose you have a very big set where billions or trillions of records are there, right? So what we have to do is we have to we have to apply our thought process in a proper way, right? Without impacting the functionalities. 1, 2, 3, 4, 5. Right? What I will do? Okay. So D type is equal to, you can write in single bracket or double bracket, both are allowed. Right? Int 16. Right? So now each element will take only 16 bit. 2 will take 16, 3 will take 16, 4 will take 16, 5 will take 16. So now total memory will be here 16 into 5. So your things will be done in 80 bits. Here it is taking 320 bits. Right? So for 1 lakh records, right? 1 lakh records, we need only 1 lakh 60 bits. Right? But here, no, we need 16 lakhs. But here, 4 times extra is taking. Right? This will take 16 lakhs bits. Right? But here we are utilizing 64 lakhs bits. So this is how like NumPy allows you to save your memory. Okay. Team, got it?
Yes,
Kedar.
Kedar.
Yeah.
Yes, Kedar.
So very big programs like will not work in our Jupyter notebook. Okay. Very big programs will not work in our Jupyter notebook. We have to go for GPU. In CPU it won't work. In GPU only we have to go. For that we have this Google Colab. Okay. Yeah. Welcome to Colab. What happened? Write code. I was doing something. once you click here, Google Colab is a machine learning compiler, or like you can say machine learning uh, Jupyter kind of. It is a notebook only, which is given by Google. Okay. Once you click here, it will ask you to sign in. Yes, you can sign with Google and just create a new notebook. Yeah. Now I want to compare something, guys. Okay. So I'll suppose I have 10 lakh records. How to compare in uh, Python list versus Numpy. Give me time. So I want to showcase you that Numpy is 10 to 100 times faster. Okay, let's do. It is 10x, 100x is that. Okay, so my machine might crash. Okay, so cancel. Fine. So I am opening something here. So I'm 10 lakh. Okay. Creating a list. It's just calculating list time, start time, and end time. Okay, let's see how much time it takes. Python int too large to convert to C int. See how much it is possible. But in real life, we need this. So there is. So our CPUs will not be able to do it until 10 lakh only doing. Aha. Okay. Until 10 lakh it is doing. Okay. One more. So it's taking time. It is calculating, but it is taking time. So how much it is? It is 10 Arab, means 10 billion. Okay. So far it has not, but in Amazon and other website, we need this kind of data. Okay. It is still working. Yes. Okay. So my laptop is not responding. My laptop is not responding. I'll just go to collab. Saying right. Um, my laptop is gone. It's not working at all. So here in Google Colab, there is some inbuilt GPUs are there. So it might work. Are you able to hear me? Because my laptop is not working.
Yes, Kedar.
Okay, okay. So Zoom it is since outside. Browser gone actually. See here also it is hanging. And session is started with a crash and all. So what I'm saying is this is normal Python list. Okay. Normal Python list takes lots of time to do manipulation. But in real machine learning models, right, you have to analyze very big set of data. It's timing out. Okay? This also timed out. So what we will do is we'll go for NumPy. Everything became unresponsive. See, this works. Not sure if it is still working. Okay. Time taken is this much. How much time it is taking? See here. So we can pass same value. N. Okay, so same value is being passed. So it took some time. I mean 72 some second, 0.72 second. And this one is taking immediately, okay, 0.1 second. So it is like 10 to 100 times faster. Once you do the manipulation with the larger number of data data sets and all. So you got it right. Why are we using NumPy? Because
Yes.
original Python list will crash. Now I'm giving very big value. Okay, let's write n here. Very big value. N1. Let's see. Touch or not. Memory error. Okay. We don't have GPU, right? So error again. But at least it's not crashing. Unable to allocate 745 GB for an array with save this much and data type int 64. Okay. So to overcome this, we have to have GPU machines. Okay. So this memory problem are coming, right? So Python, if you are using normal list, right, it will crash for big data set. But NumPy will not crash. Right? It is 10x to 100x faster. Okay? But in order to do the calculation for big data set, we need GPU machines, okay? Not CPU. Our computer is only CPU. Okay? So we will have it in Google Colab, or we will deploy in some IBM's open environment are there. There we'll do. Okay. So hope so far NumPy is interesting, guys. Now it took 1.14 second, okay, but it did not crash. Just now it got executed. Okay. So just now we only learned like how to create array using np.array method. Right? There are some special arrays that we have to learn. Special arrays. This is also like another method of creating arrays in Python. Sorry, NumPy. So shape we have learned, size also endim we learned, D type we learned. Right now, special arrays. First one is numpy dot zeros. You can write np dot zeros and give 5. Okay? Or you can give np dot zeros 5 comma 5. So it will create arrays, okay, of 5 into 5, 5 rows, 5 columns. Here it will only create zeros of 5 elements. Okay, we'll do this now. Okay, so D we used E equal to np dot zeros. Just type 1 sudo and print E. So it is creating an array having 1 0. Increase it to 2. You'll have 2 zeros. 3. You will have 3 zeros. Now give 1 comma 1. So it will have 2-dimensional, 1 row, 1 column. Cannot be 1 comma 1 as data type. Okay. Okay, 1 comma 1 is 1 only. Fine. So give 2 rows, 2 columns. How to create 2-dimensional? Zeros. No, no, no. So 1 minute, guys. I think some syntax error is there. We can create 1 comma 1 also, but we have to provide another bracket here because we are increasing the dimensions. Now 1 rows, 2 columns. 1 row, 2 columns. 1 row, 3 columns. Now 3 rows, 3 columns. But getting right, we can create 100 into 100 also. Yeah? So the most widely used operations are these. Suppose you don't have any data, right? You can quickly go and type np.zeros 1000 into 1000, okay, and put them inside a Excel sheet. In Pandas class, we learn how to how to import or export these values. So it will create 10,000 into 10,000. Right? So your Excel sheet will be filled with 10,000 rows and 10,000 columns. Okay. Once we will connect this code with Excel or CSV file. So it is used for your test data creation. Okay. But now this zero does not look good. Right? What we will do is, um, let us do here. So I want 5. 5 zeros is coming. But 0 point, 0 point, okay? These points decimals I don't want. Okay? What we can do, D type is equal to, we can give int. So int is not defined, maybe I can have int 64. So all become 0, right? Now you can create 5 comma 5. Yeah. I'm showing error also so that you'll know what problem might come. Clear? Now it is. You want 30 rows, 30 columns, and all zeros. So our test data is ready. Okay. We'll also know how to manipulate this zero with some other value. Okay. But let us learn the whatever is desired. So we learned special arrays np.zeros. Okay. We also have np.ones. np.ones 5 comma 5. Let's do this. All these things we'll be using when we actually start data manipulation. Okay. Now your fh np dot. So basically what we have to do, import numpy as np. Okay. Now I'm taking array np dot. Since we have imported in the beginning itself, no need to write again and again. But whenever you are doing in some different notebook and all, please import numpy. Otherwise, it won't work. No? Uh-huh. np dot once. One and print f. So all are floating points. np dot once. So one has been created. Suppose I want 1 comma 1, or suppose 3 comma 3. It will give. Okay. We have to give another bracket here. Okay. So 3 rows, 3 columns came, but this is decimal separated. So what you can do is here, right, type d type equal to int 64 or 32, whatever you want. So all became integer. Right? With float was not looking good. So and manipulation of float will be difficult. So we can do it like this. Anybody has any doubt? What he will give now? We can do like this also. 3-dimensional. Suppose you want to do one more. So 4-dimensional. Now you are understanding now. So dimension you don't want to calculate. You have to create that kind of data. Okay. So now it is giving us. Right? So using NumPy, it is very easy to create n-dimensional arrays. Only one statement. Correct. See, I'm able to create test data for it. It's crashed. It's crashing. So it is not able to create that much. Yeah. Okay, team. I don't want to overload today. We have to do many things. Okay? But let's go slow. Is there anything bothering you guys, or
No.
you're able to understand
No,
properly?
Yes.
good.
Someone go to mute. Who is talking? Someone is okay. Some quarrel.
Yes, yeah, this
Something.
is my thing.
Okay.
Yes, last week you uploaded that YouTube, right? It
Yeah.
was very useful. Whenever I'm traveling, I
Yeah.
go
So,
to that. Very
but
great.
okay. So you reminded me YouTube, no? YouTube. Okay, I'll upload in YouTube only because you guys can directly watch it. It
Yes,
takes 1 hour to generate recording and
Mm.
that's nice.
yeah.
But that was very useful.
Yeah.
Thanks for that.
Switch account. Which is my channel?
Bro, I just have to drop off. So to
Yeah. Go ahead.
my daughter. Yeah. Thank you, everyone. Thank you, Kidar.
Thank you. Okay. So, but if you see, I have not seen. If you see, very few of you are watching actually. Where it went? I don't know YouTube and all how to do manage videos. I think very few people have watched. So the purpose was you can take notes and watch also. Okay. So go ahead and do. I know last week, I don't know, for 54, I gave permission to public. Huh? Yeah, no problem. No personal information is there. So last week you guys watched and yeah, but previous and all very few views are there. So make sure that you are watching this and taking notes because from 2 or 3 more weeks we will have time. Otherwise, we will be completely busy. Maybe I have to increase the timing to 3 hours also. Okay, team. I'm stopping the recording here. Anybody has anything to tell?